fire the tweet. Tweet is here. What else do we need? I need the Twitch dashboard. How do we get the dashboard? Create a dashboard. Stream manager. This is fine. This is fine. This should be in here. Things are looking good. All right, I think we are set. We are good to go. Okay, what do we need? We need first thing, we should be able to sync the data with Google Sheet. Second, we need a plan or we need to optimize that watering algo. These are the two things I need to do today. Okay, I think those two things should be on the top right side. Yes, it's there. Let's get into this. The algo looks super simple now. We have 2 pins. And then let's rename this to pump pin. Let's rename this to pump pin. This should also be pump pin. And yes, we need to do one more thing. We need to learn CPP on the way. Variables. Wait, how do I declare a boolean? Bool. Okay, I'm gonna say bool is pump enabled. For now, I'm going to set this to false, and I have to Gradle. It's very familiar name. It's a very familiar name. Thanks for the follow. For debugging purpose, we need to disable the pump. So how do we do that? We simply define a boolean and then we wrap the pump operations in the if condition. This is also a pump operation. Let's say is pump enabled. Okay. Now we need a function. How do we declare a function? Where is function? Variables, user input. What is user input? That's the CLI user input. How do we declare functions? Where is functions? Structure. To create a structure, use the struct keyword in the. Okay. There we go. Functions. How do we declare my functions? You type the return type. You write the return type and then this is just the normal usual way, I guess. Okay, call a function. How do we call a function? We simply call it. Cool. Now, how do we call a function with argument? Declaration, blah blah blah. What is this? If you said the main the error. You have to declare it above, I guess. Okay, I'll declare it right above. How do I wait? Where is function with arguments? That's function parameters. Parameter. Okay, fine. So what I need is upload data. Upload is enough. What do we need to upload? We need to simply upload a message. It's more like a log. So how do I call this? Do I need to define any data type for this type? String f name. I think we should the following example as a function that takes a string called f name. Okay, I think we should define the data type also here. Oops, string message. Make it short. Okay, now I have a bunch of code I've written for the previous project to upload this to Google Sheet, but before that I need a new Google form. Okay, that's how we push the data without any SDK's API key. So hold on a second. Okay. Give me a second. So, yep. We need this function in here. But before that, we need to create a Google Sheet. Okay. Let's create this Google Sheet. I'm gonna call this project green. Okay. The first data we will be, I think we only need one field, I guess. 2 field would be better. I think we can have 2 fields. One is soil moisture. This should be a required field. The next field we need is message. Yeah, and that also will be short answer, one which is required. Anything else we need? No, I think this is fine. All right, now what we need is we need to publish this. This is required. Why there is no star in here? Yeah, it's there. Send, and we need to get this link. Once we have the link, let's store this in our floating text. That's our form link. We also need to do one more thing. We need to attach this to a sheet. Responses link to sheet. Yes, project green. Now we have a sheet linked to this. Okay. Now what we need to do is we need to create this function first. Then we can refactor this function from here. So what we need is we need a string value of m data, so moist data, and then a string value of message. Okay. what do we need here? We need these Arduino board. I think we can have this. THT we don't need. I'm going to put this include at the top, and then that's my Wi-Fi credentials, which is okay. And then we need to connect to this, correct? We need to connect. This will be the Wi-Fi connection code. Sorry, Wi-Fi connection code. Wi-Fi STA. What is Wi-Fi STA? What is this? Let's see. What is STA? Wait, what is Wi-Fi STA? Wait. Where is that? Wi-Fi STA. Oh, sorry, Wi-Fi STA. Station mode, the ESP that connects to an access point. Access point mode. Oh, station mode. Yes, we are connecting to station. Connecting to Wi-Fi. While it's not connected, we wait for 1 second until it's get connected. We don't need, connected, and then we already need to create this here. Okay. Cool. We have the Wi-Fi connection now. Now, what do we need? We need Wi-Fi for Wi-Fi connection. Yeah, if it's connected, we are going to sync the data. That condition should be in here in the upload. Okay, and in here we are doing a couple of condition checks. Then comes the Wi-Fi client secure. Wi-Fi client secure thingy. I don't think we have to do this every time. HTTPS begin. Well, we will optimize this later. Now we will do paste it here. It's probably creating an object called client and then disabling the SSL thingy, creating the HTTP instance. Wait. We shouldn't delete code from here. This is also a working project. Yeah, this is how we push the data. Okay. So the form URL, this is the old form URL. We have to change this. I think we only have to change just one part, which is this key part. Correct? Yes. Rest I think I can keep it as it is. Okay. But the key looks different, no? No, it's almost... No, wait. Did the key look different? Yes, it did. It did look different. I mean, the key at the end shouldn't have any format, but I see a hyphen in the middle. It shouldn't be a problem. Okay. Yeah, that's our new key. We'll confirm that. We will confirm that by... We'll get this form link. And then we'll go to incognito. And we will be checking, we'll be firing one sample, fire, and yes, we have the form response call, and the key is 1FA, which is matching with our key. Correct. We need one more item from here. Where is the payload? Payloads will have two keys. Okay, 5020 is for the sensor data, as in the moisture data that we will paste here. Then we have 3106 for the message. What am I going to do here? This will be a float, I guess. Moist data is going to be in float. I think so. Oh, sorry, it's an int. So we need to convert that to a string, and we need to also convert our message. Well, we don't have to convert, we just have to attach the, we can just I think we can just call it like this. Okay, we pause this and we wait for the HTTP code. We have we're waiting, we are just printing the HTTP code, that's fine. Cool, then we end this, then otherwise we'll say unable to connect. Okay, then we'll skip it. Here we will say serial.println Wi-Fi connection not available. Connecting to Wi-Fi pump, enable moisture data. We are observing the moisture data in here. Sensor data is in here. Yes, we have a function now. Now we can start calling this function. So upload sensor data will be our moist data. Okay, and the wait, the message is also int. How come? Why I'm not able to navigate to this function? Wait, how do we define the function? Doesn't look good with the syntax highlighting. Okay, how do we define the multiple params? So multiple params are different. No, you can add as many as we want. Okay, then what's the problem? What's the problem with multiple params then? Why the string is not getting highlighted? Do I have any typo? No. I have the comma in here. Oh, I forgot a semicolon. Is that why it's not working? I think probably, I don't know. Let's, where is the vibration came from? We'll say watering, and in here we say I think we shouldn't do this in here. Okay, it will be watering for 3 seconds. Semicolon. How do we get the pump status? We shouldn't. We can maintain a boolean is pump on equal to false, and when we turn on the pump we set true, and in here if we pump on we will upload the message sensor data stopped watering. Okay, and then we will say is pump on equals to false. Okay, cool. And inside upload function I think I will do one thing. I think I will log this thingy. Logging is not needed, or needed, I don't know. Let's log it anyway. Println uploading. Oh my god, Kotlin coming in. Can I do this? Can I do this, boys? I don't know. Let's try to compile this. Oh, it won't compile because I might be missing a ton of semicolons. That's what you get when you code in Kotlin for so long. Okay, I'm missing a semicolon in here. And what else am I missing? Should be that. Let's compile and see what's in there. Meantime, we can look into, oh my god, there is another. Is pump on. Okay. Where is that? Got it. Got it. Anything else? I hope that's it. Again, verify. We need to connect this thingy. We need to make sure two things. First thing, yeah. What is this? Initializing argument to avoid invalid conversion from const char to int. What does that mean? What does that mean? Second param is message, which is string. What's wrong with that, bro? What's wrong with that? It's just a string. Hey Chad, how's it going, man? How's your weekend going? We are doing some CPP stuff, I guess. Why we are getting this invalid conversion from const? This is the first time I'm writing CPP, so you have to see this. Initializing argument to, how come int is not int? I said it's a string. Wait. I recently found out Windows as alone took 200 GB space out of my 1 TB hard disk. Wow. I think it's been some time I used Windows. I think it's been 8 years, I guess, I touched Windows. Well, we need to go to our teacher. Why do I have to define string as the first param? Is there any rule like that? Huh? I hope we don't have such rule. Well, we string, wait, let's paste this and see what, not upload, my funk. How do I do this? We do need to do one thing. which is wait, C++. What's wrong with this function? So memory management, wait, that we'll get into. I need to know the basic things. I think I asked it too much. Maybe we need to optimize our question a little bit. We can wait. We can, yeah, serial.println MSG. Okay, and now we will ask. The function is missing a return type. Bro, it's the void is the return type, right? The function doesn't return thing, it should be declared as void. The heck? There is a typo in the serial message line. It should be serial print typo, that's fine, but the first one is wrong. Is there any? Okay, how do I call this function from another function? Show me some samples. Okay, that's exactly what I'm doing. But then what's the issue? What's the issue in here? Let's try to compile again. Chat, how's the background music volume? Is it too much, too low, or good? Okay, initializing, I'm reading it again. Well, let's start from the head. String has not been declared. Why string has not been declared? What does that even mean? I can't use string directly in here. Do I have to use char array? Is that what you are saying? Is that what you are saying, bro? Is that what you're saying? Well. How do you know? ID. I think that's what I'm using. Yeah, what is this thingy? I am new to this and trying to do my best. I'm setting up a remote water tank level indicator using blah 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 blah. I think he is also having the same issue. What's the answer? Okay, is there any string usage? That's what I need to see. Next, you try to assign as a pointer of string. Oh, okay. It's about the data type and how you pass it down, I guess. But this in here, it's different. Now what is this? ISO CPP for converting a string constant to char. Okay, now how do I do this? Tell me, how do I do this? Do I have to define an array? No, right? Oh my god. No, I can't do that. I have to have string. Okay, let's go simple. String doesn't work with such a stupid thing. String type is not working. Yes, there we go. Why? Do I have to make these gaps? Is that the issue? String, okay. I guess that was the issue. String is not a data type, it's a object, I guess. Wait, where is this uploading? I haven't connected this thingy. Wait, let me connect this. And that started the pump, which it shouldn't have. Now we need, okay, it's starting the pump because our moisture sensor is not in the water. Okay. We need water to prevent this. Hold on a second. Now, let's put our moisture sensor into water. Okay, it's in the water, but I think it's too much water. Do I have to decrease the water level? Maybe. Where is my... Yeah, I think that's fine now. Okay. Is my cam stuck? I think my cam is not working at all. Oh, that's an issue. Hold on a second. Let me fix my keyboard cam. This is Arduino or something. This is ESP8266. Cheaper than Arduino. I don't know why people are going for Arduino. It's much expensive than ESP8266. Like it's 2,500 in India, and then ESP8266 is like 300 rupees. And this thing also has Wi-Fi. I don't know why people are going after that, but there should be some reason. I am very noob at this thing right now. I wouldn't know. I think it has too many pins, too many analog pins, I guess. This ESP only has one analog pin as far as I know. How do I fix my cam? Shouldn't be. Yes, we will take this device. How do I power this thing? Well, let's fix this cam first. You wouldn't know if I get burned or something that's happened. I'll show you. How do I connect this? Okay. Give me a second. My camera is basically an Android device. It needs to boot up. For some reason it turned off. I don't know why. Okay, we have this guy here. And I think I can open the IP cam. IP should be same, and we should have some visual right now. Or I think I need to refresh this keyboard cam. Should be fixed by now. I hope it's visible now. Cool. Now we have the sensor in the water and we can plug this boy. Just developing software is easy. This is okay. We have space issues. How do I connect this thing? Okay, we have another port. We don't have a port in here. We should connect this in here. Okay. Let's look at our serial monitor and see what it's printing. Let's push this data. Okay, we need to verify if we are getting our data, if we are getting this thing in here or not. So this one, okay, wait. This one, let's close this. Let's put this in focus. It's uploading. Usually uploading looks different. I don't know why this time. Okay, it couldn't find the port, I guess. So mine is, what is this thing called? Node? No, ESP8266. No, yeah, Node MCU, serial port USB. Okay. Let's try to compile and upload. Okay, it's uploading. Let's put this little more deep into the water. What if it couldn't get the right value? Okay, so yes, we have the code pushed and done uploading. Let's look at our serial monitor now. We see some data. Let's take this and let's put it in here. Do we have anything, any good thing happening? No. Why we do not have? Let's try it one more time. Oh, wait. I think we are looking at the wrong serial. Yeah, let's wait. Okay. So let's wait 570. How can I pin this to bottom? Wait, how do I pin this? How do I pin this thing? Let's close it, and I think is there any way like we can reset that? Okay, this is someone else's thingy. This is not it. March 16. Is that it? Yeah, should be this. Okay, wait, let's close this. Let's close our serial monitor. Let's open it now. Then let's connect. And yeah, this should be the Wi-Fi connecting. Okay, we have the sensor data now. But why this thing is not pinned to the bottom? Why it's not scrolling with this thing? Oh wait, let's try to pull this out. Let's put it back. Do we have any data updated in here? No. Why is that? We need to reduce that time to something like 2 seconds or something, just for debugging purpose at least. Okay. This is 96100, right? Serial port. I hope we are not burning anything. Things are looking cool. Okay. How do I pin? Is there an option to do that? What is this? Is that it? No. What is this? I think that's the option. Now we don't have to scroll down. Okay, that was it. But what was this then? Oh, that's the time. It's fine. Now the soil is wet. We are stopping the motor. If I pull this out, we have dry soil. It now says watering. Now let's put it back and see if the data is synced or not. No, it didn't. Why? It didn't call the function. Oh, we didn't enable the pump. That's why. We should. Yeah, well. There is something we need to change. We can, yeah, put this outside of that block, and this also. Since we are debugging, I turned off the pump. We're just focusing on syncing the data. Let's upload this. Okay, we have the soil is wet now. May I ask what exactly are you doing with the sensor and what data are you adding to the Google Sheet? So I am syncing, I want to sync the sensor data, which is the moisture data, the moisture value at that time, and also I'm pushing a message. So we have two columns in here, right? So the message you see here should be sent to the Google Sheet, and that's what I'm trying to do here. Okay, so I'm pulling the sensor out. I think we have an entry going now. Yes, the data is syncing. Data synced. That's a good thing. Yes. So we can see when we watered the plant and when we stopped watered the plant. It's more like, yeah, what was the moisture at that time? That's what I'm trying to do. Now we have successfully done that. We need to optimize few things. To do this, I think, I'm not sure if this is right, if this is something that we can do. I think here I'm creating a client every time I make a request. I think I can move this out to outside the function so that I can reuse the connection, but I don't know if it's something that I should do. Or let's ask someone who is very good at this, which is Cloud3. So it's connected to Wi-Fi, and upon specific condition, it's a network request to Google Sheet. Exactly, it's connected to Wi-Fi. This ESP8266 has a Wi-Fi chip on top inside that board itself. You don't have to buy any additional chips or anything for that. And then we can build an HTTP server inside that, and also we can also act as a normal client. So currently I'm acting as a client. That's why my Wi-Fi, where is that line of code? Yeah, there is a Wi-Fi STA. It means that we are connecting to Wi-Fi station. There is a Wi-Fi AP mode, which means the device, the ESP8266 can act as a Wi-Fi uh, hotspot, or server or something like that. But yeah, that's what we are looking at right now. We have a water pump here. I've disconnected that for now. But for now, let's see. Yeah, we are focusing on it. Let's optimize. Okay, wait. We are firing HTTP. Okay, let's put that in water. Right? Let's unplug this, and we need to do some optimization. What happens when there is no water to pump? How to notify the user? Good question. That I need to figure out. I think there is a water level sensor. Is there something like that? ESP8266 water level indicator project. Yes, I think there is. Hello friends, welcome to. There is a water level sensor also, which we can integrate. Without this, we wouldn't know. What is that? Oh, that's a sensor. Hey guys, how's the background audio? Is it too loud, or do I need to? I'm decreasing it to 40 dB. I'm decreasing it. Okay. There is a water level indicator. Okay. And how much does it cost? Is that what it called? Water protection shouldn't be that. Water level depth detection sensor. That's depth detector. I'm not sure which one is that. Looks like there are different kind. Water level monitoring system, ESP8266. Yes. Let's look at that. I think it's the same project. I think that's that thing. But this is motion sensor, I guess. What is this thing? What is this thing? I don't know. Node MCO waterproof ultrasonic sensor. Why do we need too many? I think he is also having a buzzer sound. He's playing a buzzer sound. That's why we have like too many components, I guess. That's ultrasonic if I'm not wrong. Cool. The question is, how do we access it? How easy to access these things? There is a code. Where is the code? Wait. Empty tank distance, full tank distance. Yeah. The logic is pretty simple. You have to have two values, and then based on that, I think we will calculate the percentage, I guess. Trigger percentage. Nice. But what was that? What was the other thing? Pump. What was this thing? What was this thing then? Water level indicator? I hope it's... No. What is this thing? Google reverse image search. That's a what? Wait, what is that? Come on. You just showed me what was that. Yeah, that's a ultrasonic sensor. I think it's a different ultrasonic sensor, I guess. Yeah, that's how you measure water, I guess. But yeah, that's how you do it. Currently that's not a problem for us, but it will be a problem, but we'll see. What do we need now? We need to find the issues with our code, how we can optimize it. Let's go ask function by function. PPP. What are the problems in this code? How can I optimize it? While the code appears to be functional, there are a few areas that it can be improved and optimized. Here are some suggestions. Error handling. The code doesn't handle the case when HTTP begin fails. It would be better to add an else block to handle the failure scenario and provide appropriate error message or take necessary actions. That's not needed for right now. Resource management. HTTP client instance is created using new but not explicitly deleted. It is recommended to use a smart pointer or ensure proper deletion of. What is a smart pointer? Or ensure proper deletion of the dynamic allocated object to avoid memory leaks. Connection timeout, that's fine. SSL verification, that is also fine. Error logging, fine. Reusability model. The function combines the logic of checking the Wi-Fi connection status, creating HTTP client, constructing the request state, and sending the request. Consider separating these concerns into smaller reusable functions. Okay, not a big concern. The Google form URL in the hardcode in the function, consider extracting the value to consider. Fine. Performance optimization, that's what I'm looking for. I think that's point number 2. How do we, can you show me examples for point number 2? The PRSSL Wi-Fi client secure objects created using new, but it's not good. Then if the object is not properly managed. Here are a couple of examples how you can handle the resource management of the. Okay. Wait, using a smart pointer. What is a smart pointer? What is a smart pointer? What is smart pointer in CPP? I need W3 schools. They explain it. Yes. You learned how we can create the memory address of a variable using the AND operator. Okay. The output the memory address of fine. A pointer, however, is a variable that stores the memory address as its value. Pointer, however, is a variable that stores the memory address as its value. Okay. A pointer variable points to a data type. My friend had done a project with the sensors that he saw on YouTube. Use the sensors to gesture control the laptop. Pointer variable points to data type like int or string of the same type and is created with the star operator. The address of the variable you are working with is assigned to the pointer. Okay. We create a data type. Then we create a pointer. Output the memory of the food with the pointer. Okay. How is that going to be beneficial for us in our scenario? What was that ping sound? I meant. Unique pointer. Okay. Where is that? We are already using it. STD unique pointer is there. Is Wi-Fi connected? In the example, string is pointed to manage the lifetime of the USB object. The client object is created using. Lifetime of the USB object. The client object is created using new, but it is wrapped inside. When the client object goes out of scope, when the pointer the function ends. automatically release the object, ensuring proper memory. It's already there. What are you suggesting? Manual memory management. This is fine. This is actually fine. My question is, do I have to create this client every time? Okay. What do you think about moving the client outside the function and reuse the client for each upload request? It can help reduce overhead of creating and destroying every upload creation. Here is an example of how you can. Okay. Client.reset, initialize client.secure, return true. HTTP client, HTTPS, client start, begin, start client. Where are we calling this initialize client? If client not initialized, fail to initialize client. Client is null. I think we can try to do this. And how do we know how much memory we are saving here? How do we know if we are making an improvement or not? To know that, we need to understand how much memory we are using. How to know? Wait, ESP8266 RAM. How much RAM we have? How much RAM we have? We have 32 KB instruction RAM, instruction cache RAM of 32 KB. It is user data RAM. I think we have another question. When I declare a variable, in which memory the variable stored? In ESP8266, will give them the option. Memory allocation of variable depends on the type of variable and how it is declared. Here is a breakdown of global and static variables. Okay, that's our case. Global variables are stored in the user data RAM, which is the 80 KB RAM available for user programs. Okay. Local variables including function parameters. We are not talking about function parameters. Dynamically allocated memory. Memory allocated dynamically using functions malloc or new is also stored in the user data RAM. That's fine. Instruction RAM, I don't think that's what we need. I think we need to check the user data RAM. Okay, next question. How to get ESP8266 user data RAM size? The size of the RAM memory is there is no programmable ROM in this, so therefore user program must be stored. Wait. How to know? How much memory? Yes. When using this command, how much memory is available? How do we know? How to get free user data memory size in ESP8266? Read out free RAM. Free heap RAM goes down with each web page request. Yeah, I think people do observe this. ESP.getFreeHeap. I think that's the variable we need to worry about. Yeah. Yes. ESP, found the ESP, I think this is something. Is there a function to read out the actual free RAM size? Yeah, found the ESP, but I think this is something different. blah blah blah, blah. How did I think the amount of free heap space is exactly the amount of free RAM is usable by application. Okay. Is there any other method anybody suggesting? No. So the method we are looking for is this one, free heap. So now what do we do with it? We should print the data. Okay. And free heap, I guess, is returning an int. So we can say free heap. And then just like we print the sensor data, we will also first print the free heap. Okay, and we will observe this data for some time. For that, we won't be printing anything. Okay, wait. I think it's okay to print. Is there any way to filter things out here? No, right? We are working in a different scenario. How do I search? There was a search bar in here somewhere. There was a search bar. I remember. There should be a search bar. However, oh my god. Oops, doops, oops, doops. Okay. We have our board connected. We have this in here. What else is missing, bro? What else? What am I missing? Okay, it's not connected, it says. I always have to come here and do this. Okay, fine. Now we have free heap getting printed. Let's look at that. Let's upload this code. Let's look at the free heap. Serial.print. Oh, this semicolon, yaar. What are we doing now? We are optimizing the code. Okay, let me update this. Optimizing memory. Okay. Okay, we have the code being uploaded. I think now we should have this. Yes, we have the free heap. There is no way we can filter this thing out, I guess. Why this thing is so limited? Okay, what we have is we have a free heap of 49672. Okay. Now, let's say we are firing an HTTP call. That will make the free heap goes to, wait, that makes the free heap goes to, it's the same. I don't think we have like huge impact on that. Let's fire a few requests. Let's also make sure our data is still syncing. Yes. Yes, it's still watering. It's still watering. And 49672. What was the previous number? This was also 4950. We started 672. still 672. I don't think there is much going on here. Like, the object is anyway deleted, so memory advantage is not there. What we can do is we can yeah, there is a memory advantage I can see here. What we can do is we can do one optimization. How much time does it take to fire that request is what we can check. So free heap, we don't have any heap issue in here, so we can skip doing this. And now we need to measure things. So now we'll go to Claude and ask, great, I have another question. How can I measure time taken by a function to execute? Can you show me some sample? Certainly, to measure the time taken by a function to execute, you can use some millis or micros. We'll go with the micros. Function for the Arduino framework. Here are a couple of examples. Okay, we have a millis function, we store it, we end it, we find the execution time. Very simple. Very, very, very simple. Now, yes, let's do this. Let's put this on the left side. What do we need to actually measure? Should we measure the loop duration? I think that won't be fair, since we are looking at the optimization at the upload layer. Okay, so yeah, we are thinking of optimizing the upload function. I think it should be here. We need an unsigned long. There will be start time and there will be micros. Let's copy this. I don't want to waste time in here. This is not my area of expertise. I may make mistakes. The end time, then we'll print execution time. Fine. Very simple. Where is our end of execution here? Okay. But I think we should measure this in here whenever we are firing because I think that's what we need to measure. Otherwise it doesn't make sense. We may see wrong data. Execution time, measure, blah 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 blah. All right, we have this thingy. Now, how do I make this even easier to debug? I think this is fine. Yeah, let's test with a real world scenario. Don't want to create a mock testing scenario for this. This is fine. So what we need to look for is we need to look for the execution time. We need to connect this. We'll get an error saying we don't have a device connected, which is true. We need to go in here, select the USB serial, and let's wait this to fail first. It's failed. Let me try to re-upload this. Okay, we are uploading this. Okay, we need to put our sensor in the water. We were firing HTTP calls here and there. I guess our sheet will be filled now. Okay, stop watering. Okay, 2573 microseconds. Okay, now let's look at the time. Let's note down this time. we have 23169, then we have 26453. This is what you have to do when you don't have a filter option in the logs. Okay, 18. Then we have another one. Then we have a new one. But I think this includes the call time also. We need to minimize that. We need to avoid measuring that also, I guess. That's why we are getting an extra number sometimes. That's a huge difference. That's a 747 digit, and that's again 7. Fine. I think let's 253. Where is 253? 423. Sorry, where is 243? 243 is gone. But yeah, we only need this one right now. Now we have the data before. Now what do we do with the after? Let's see. I think we need to remove this. We need to put this before firing the call. We are talking about the setup time, not the firing time. Firing time will also have impact. No, it won't have impact. What we need to do is we should let's put this in here. Let's stop the HTTP calls for now. Stop watering. Okay, now let's make the optimization as suggested by Mr. Opus. Where is the optimization, bro? Yes. So we need to do one more thing. This is before including call. We need few samples outside excluding the call. Okay, we should place it here. After how much time does it take to create this client? Yeah, how much time does it take to create the client? Or let's say, yeah, how much time does it take to create the client? That's what I need. Any of you guys know any other IDEs that I can use? This thing doesn't even have a search. I can't even search and filter the logs, which is really needed. Wait, let's search how to filter JetBrains CLAN. Does it have this Arduino this thingy support? I don't know what to even call this. Does it have this Node MCU development support and all? Ankur, how to filter logs in Arduino ID? Arduino should be there. Maybe I am missing it. Yes, how do we filter specific message coming from Arduino? Oh wait, we have to do this at code level. What is this? Doesn't look like an IDE guide. Conflict filters library referenced by IDE. Filtering serial data. 3 methods not filter. I don't know, mate. I never tried to steer out Arduino default IDE when working with such chips. Yeah, the IDE is cool. Like when you want to load libraries and all, it's really cool. But few things are missing. Maybe we can write our own function, but I don't know. Yes, now we have our new set of data coming out of this. Now let me put this execution time. Okay, this is 334. This is again 334. Creating a client takes 334 microseconds, which is okay, I guess. You don't have to, it's not much time, it's just microseconds. Yeah, it's almost 333 seconds. But still, let's see if we can do something about this. Like if we move the client outside the function, how does it going to be? I'm just curious, that's it. I'm just simply curious. And how do I save this? Let's save this data somewhere. Okay, that's my git commit now, at least for now. Yes, where is our Wi-Fi client initialization? We will do it in here. Okay, and then what else do we need to do? We need a function called initialize client. Okay, I'm going to put this in here. Now what else? We have a function that fires an HTTP request. That's fine. Before firing this thing, we have to do few things. We have to check if the client is null or not. Okay, I think that we will do inside this function, and then I'll remove these two lines. Okay, now I'll also move this line in here. So this is wait, this is before just int, and we have execution time in here. We have our HTTPS 2. I have to create this client also every time. Yeah, I think I have to. I think this is the request, not the client. Should be called a request. This should be a request. This should be renamed. Is there any way I can rename symbol? Oh, I can. Request. Makes sense. Now it's more readable. What else? We have an end call. We have a post data. Okay. This is okay. This is fine, but let's see how it acts. Let's see if we are saving some time anywhere. Well, how we need to find a average of this? What's the average? The average is 267555656. What's the average of this? Yep. Okay, we are uploading the code. We will have the time now. We have 190. Okay, can't type this. We need to copy this. 190. Is it too much or too less? We'll get 7 samples. Okay, I think this is not fair. So like comparing the number that includes HTTP call, we need one more. Okay, I think we have 7. I think we have improvement. We do have improvement, right? 7. Yeah, we do have improvement. We do have improvement. So let's chart this out. Before run 1, before run 2, before run 3, before run 4, before run 5, and before run 6, and before run 7. Oh, it didn't work. But wait. If I do this, wait, before doing this, I need to check few things. 1, 2, 3. I'm drawing this in one line. Okay, A, B, then C. That's how you draw things. So what I need is, I need to format it like this. Before A, B, C, D, E, F, G. Okay. Now we need to get this data in here. This is after A, B, C, D, E, F, G. It's a mix, but the average looks better. The last one, I think it spoiled the average. At last it took some significant time. If there was no, if we remove that element, I think, yeah, the before is somewhat on the higher side anyway. Correct? Then we can do that. We can put our client outside this. And let's look at the heap size also. Since we are, yes, we should also look at that. Where do we print this thing? We need to look at our heap size also. Okay. Heap. That's the function, right? Free heap. Oh, not val. How do I say this? Int. Free heap. Then we say free heap. This should be the ln. Yes. Here. Oh, we can measure the water remaining by the we don't need a sensor to check if we have exhausted the water or not. Like if we know how much water we have in the source or in the big bucket, by measuring the flow rate of this 5-volt motor, I think we will be able to figure out how much water we have. Yeah, that's something that I need to do. We need to measure water. Yeah, let's update. Oh my god, I put this in a very serious file. It shouldn't be here. This should be here. calculate water balance. How do I say this? Calculate remaining water. Okay, that we need to do. Okay, now let's look at the free heap. Is the free heap dropping? Is the free heap dropping or not? Let's see. Let's see if the free heap is dropping or not. I don't think it's dropping. Stable, somewhat stable. Oh wait, what the heck I'm doing? It's not free heap I was printing, it was the micros. That's what you get when you copy paste. Wrong data. I really wish we could filter this log somehow in this IDE. Wait, node MCU IDs. I think the most famous IDE is this one only. Let's look at the free heap. Let's look at the free heap. Do we see any drop? Do we see any advantage? Is my question. Okay, there we go. Free heap. Isn't too low compared to what we had before? I think heap is it dropping? It's regaining. It's not dropping, but I do see some difference. 214. I know it's not dropping. It's keeping up. Oh, that's a big drop. That is fine. Regained. Yeah, now let's look at the chart. Heap fall. So how do I do this? This is also a heap fall. This is also a no. Naming is hard. I need F3 to A B C D E F G H. I think it's doing more like a zigzagging. What's it? It's still at 21. This is fine. Heap is fine. I think we probably saved slightly like a 300 microseconds or something, but that's not big. This is fine. So the lesson is we don't have to worry much about these things. I think most things language taken care by the language. Blah, 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 blah. I think we can remove this. And do we really need this? I think we can use this. It's a good thing to have, in my opinion. I also need to understand if there is a way we can get the CPU temperature. How to get? Wait. I think I'll open this up. How can I monitor my ESP8266 health? How do I get free memory? I know. How do I get CPU temperature and other critical metrics? Yes, this is what we need. To monitor the health of ESP under you can use the built-in functions provided by the ESP82 core. Here is how we can do it. blah 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 blah, get VCC, read the internal voltage reference. What is VCC? Temperature. Oh, temperature. Oh my god, we have CPU temperature. Yes. Let's observe this. This will be fun. This will be fun. We really need to have a filtering logic. So we need a filtering logic. How do I filter things? I'm going to declare a function. I'm going to declare a function log, and it accepts a message. Okay. Oh my god, why I'm writing Kotlin here? It accepts a message, which is a string. Okay. And it checks for certain type of message, and then it prints if it's the, yeah, that's what I need. That's what I need. I can also pass. Yeah, I don't have to pass things out. I can use a string concatenation here. So if message contains CPP string contains, how do I check if a string contains a string in CPP? How do I do this? Oh my god. Oh my god. Oh my god. Yes, this is why we all love Kotlin. Message find. Okay. Find temperature. Let's say, then print this thing. Wait, then print serial.println message. Okay, find what? Find. Don't want to type this mess. Okay, then only we will print. That's simple logic. Okay, now let's compile this and see if there is an issue. There will be issue, obviously. I miss semicolons a lot. What else? Oh, wait, what was that? What is this? Incomplete type end post. Bro, this is what Stack Overflow told me. Can't complain. I don't know how to fix this. Incomplete type. std string aka. Incomplete type? This is from 2010. And people are suggesting you can try using find function. str2, there are two. Everybody is using this. Why are you complaining it? Do I have to include string? Oh my god, I didn't know contain checks are this. These are coming from 2015. Let's sort this by date created. Oh, no. Date modified. Trending, top recent votes. No. I need something very simple. Okay. I need something very simple. Why are you making this hard for me? Stray message or find. Oh my god. Wait. We have a new follower. Capilis 500. Thank you for the follow. I hope I pronounce your name the right way. We have an index of thingy. I think this string object is much more mature than the native things. Another follow. Thanks, Ankur, for the follow. There should be a contain check. There is a last index. Index of. I think we have an index of thingy here. Wait. String contains check C++. Yeah, come on. Help me out here. Why this is so hard? String S1, S2, we have two strings. This is fine, right? Why are you making this so hard? How about now? Are you happy? You are still not happy. Okay. String and pose. Why, bro? Can't stand really long on the stream since I have to study, but I want to thank you for nice tools and content that you create for us, the Android devs. You're welcome. Appreciate the kind words. Yeah, this thing, what is this? Why string contains check is so hard? Wait, string contains check Arduino. Yes. Yes. No, don't give me this. Yeah, simple. Index of greater than. Can we do that? Do we have index of function? Index of is greater than 0. Do we is this even a valid thingy? Oh bro, that's it. That was it. Compiled. Now the problem comes when we need to log something. Okay, we don't have to call serial.printf from now on. We can simply go and say rename symbol. No. I need to rename everything, bro. Format document, format selection. No, peak. No. How do I edit? Where is the replace? Find next, find previous, use selection for find. Use selection for find. Auto format. Where is replace? We don't have string replace. Don't do this. Do not do this. Oh my. Oh wait. We have. Oh, I also thought. Okay. That looks very familiar. And we now from now on we don't have to play with this thingy because this is string. We can append, prepend, whatever shit we want to do with this. Okay, we are. Okay, I hope these things trend first of all. Serial.println. Yeah, println we have in. How many println we have? We have 7 println, which I'm going to replace by log except this string println. Okay. Now log we have another. Oh wait, we have print also. 5 of them. I think 5 is fine. Connecting to Wi-Fi. This is fine. This is serial.print. That's fine. We don't also need this. Why do we need this? We don't need. We just simply log things. Okay, nothing, no fancy things. Simply log. And we don't have to do this from now on. We can just do that. Come on. What else? What else we need to refactor? That's our custom logger. Now let's see if it compiles or not. Let's also check if you are not burning anything. Cool, this is cool. This is also looking cool. Okay, third comes problem number 1. Tuck, 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 tuck. Tuck, 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 tuck. Can I do that? Can I just simply create an object like that? Yes, done compiling. Now let's push this. And wait, we didn't add our temperature thingy, right? We didn't add our temperature. Yeah, we didn't add. Where is our cloud boy? Cloud boy, come in. We have to add this in here. Okay. And in here, I have to do this. And yeah, this also, just to make things a little fancier. And we can just simply say log. Okay. And we are going to measure temperature, CPU temperature mainly. To make this little faster, I'm just going to reduce the delay to 100 millisecond. And this should be working. Let's see. I think I typed as lowercase here. I don't know if it's case sensitive or not. Let's see if it's case sensitive or not. By the way, we need to update this. We have pushed the data. Now we are optimizing the algo, not the algo. We are somewhat optimizing something, that's fine. Oh, wait. What is going on here? Oh, our sensor is out of this thing. Why our CPU temp is not visible? Why HTTP is visible? That's because we didn't do the formatting there. Okay. We should do this. Why first of all this was running upload? Yeah, let's reduce this to a second maybe. Oh wait, let's do it 100 ms itself. But wait, let's look at our data also. 55, 43, 35, 28. Yeah, that's a loop. Let's do one thing. Let's clear the data for now. Delete rows. And let's do this. I think we can put it here and in here. And the code on the code should be on this side. Observers should be in here. Okay. We have something. CPU temperature is 6503. Is that true? Doesn't look true. That's too much heat, right? That's wrong. That is bullshit. That is bullshit. That is bullshit. Get CPU temperature. Temperature. Let's turn this thing off for now. ESP266. Somebody please throw me some code at me, please. No code in here. That's can I get CPU temperature, CPU fan speed, etc. of a Windows PC? Not a Windows PC. I need to get the CPU temperature. Get CPU temperature of ESP. Wait, board. Can I get CPU temperature, CPU fan speed? Is this the same thing? Same thing, same thing. This is with a temperature sensor. They don't understand the question. How do I? It doesn't work. The CPU temperature logic you given, it doesn't work. It always prints 6503.50. Does not have a built-in temperature sensor, so it estimating the is not straightforward. You should have told me this earlier. DHT-pin I know, bro. DHT-pin I know. We specifically need to measure the ambient temperature. No, I don't need to measure the ambient temperature. I think we can't do this. We can't measure the CPU temperature, which brings us to Command Z's and delete. Okay, now what? Now we need to measure the water remaining. Okay, how do we measure the water remain? So my idea is, let's say we have 1 liter of water, and each pump has something like, 5-volt water pump. Maximum 1 centiliters per second. Okay, is this a 5 submersible? Yes. Wait, we need to go to Robu. Robu will tell us more detailed. Water pump. Okay, this is what we need. So the flow rate is in here. Maximum lift. Oh, maximum lift is 110 millimeter. Yeah, that we have to take care. Outside the maximum lift flow rate. Flow rate is what we need to. This is how we calculate our. Yes. Let's get some help from here. I have a 5-volt water pump with flow rate. Okay. How much seconds? How many seconds? How many seconds I can I can pump water with 1 liter 1 liter of water. Typo. Yes. So with 1 liter, I can pump for 30 seconds. Okay. Now we are pumping the water. For example, if you look our code, what we can see here, when the moisture goes above 950, we are pumping it for 3 seconds. So with this flow, we can pump what? We can pump 10 times. That's what we can pump. We can calculate that. Okay. Yeah, we can calculate that. That I need to calculate. That's actually a good thing to find. So with 1 liter 30 seconds, I need 10 liters to 300 seconds, which is 5 minutes watering. Okay. And 1000 minutes. Okay. So if I want to water for an hour, how much water I need in liters? You can know the amount of water needed based on the. I need 120 liters. That's what they're given in the flow, right? Stupid me. Yes. I'll need 120 liters of water. But that's not a big concern right now. We will come back to this. For now, we need to check how much water we need. The plant I am having is, I don't know what they call it. It's lace leaf. Okay, this is the plant I'm going to test with. Now let's learn more about this plant. How do we learn more about this plant? We'll go to, we don't need cloud for now. We'll go for GPT-4. Okay. Well, let's use cloud anyway. I want to learn more about lace leaf plant. How much water? 120, that's a gold mine as per the current Bangalore standard. Ankur, are you from Bangalore? How much water? I want to learn more about lace leaf. Is there a delay in here? Currently staying in Bangalore. Okay, fine, cool. How's the situation there? I have seen news and all. Is it improved? How much water they need in a day? And what about sunlight? And what's the watering frequency? Oh my god. Lace leaf, you don't know lace leaf? Did I put a typo in there? Let's call this anthurium. Okay. How about, don't tell me, yeah. Yes, heart-shaped flowers and glossy green leaves. Yes, that's the plant. Anthurium plants prefer medium to high humidity levels. High humidity level. Okay. They require well-draining soil that is kept constantly moist but not soggy. Oh, that's a good point. That's a good point. We need, okay, now we need to design this thing. This is funny. I don't know why I'm doing this. Okay, come on, let's give the axis, bro. Create a new diagram. Let's blank. Let's start from scratch. Okay. So since this point is actually catchy, or this is something very important, it doesn't need to be. It just need to be moist but not soggy. Okay. Now the design I'm going to do is very brilliant one. This is going to be a brilliant design. Okay. How do I zoom out of this thing? How do I zoom out of this thing? How do I zoom out of this thing, please? Okay. What's the shortcut? Command numpad. Ah. Easy peasy. Now, the situation has slightly improved. Oh man. Cool. I don't know. The weather is also. I live in Kerala. The weather is also pretty hot here. It's much hot than the previous season, I guess. I'm not sure. I actually tried. I bought this small sensor. Where is that? Yes, this guy. Are you able to see this? Yeah. So that's a DHT22. That's what they call. Yeah, I bought this sensor, by the way. It can measure the temperature and all. The temperature and the moisture in the air. So I collected this data for a day from the same ESP8266, and this is what I came up with. These drops are indoor checking. This is with AC and without AC. Okay, this is with AC. With AC, temperature was more like 27, and then even though I put it to 21, it was only getting 27, and then without AC it was 30 degree inside, and this was happening 10 p.m. at night. And then I put this outside, and that's when I saw the increase. This is morning 7 a.m. It was 27, and then it spiked to 30, 31, 32, 33, up to 35, 36. Yes, and at that time the humidity was also like 54 only. But yeah, this is night time. Humidity increases, but temperature not much difference, 35 to 28, 29. But yeah, still hot. But yeah, yes, let's talk about the design. Okay, so I need some shape. I need a water tank. Can I get a water tank here? No, bro, you don't get it. Oh, we have a water tank. That's a tank. I need a water bucket maybe. Can I get a bucket, please? Yes, I can get a bucket. Okay. That's an S3 bucket, right? Oh my god. Okay. So this is where no, we don't need a bucket. I think that's confusing. That looks like a plant pot. We need, I think we'll go with this shape. Okay. This is where we put our water. Let me improve the. Okay. Okay. Now this is our water thingy, and on top of this I will make, where is a 3D square box I can draw. Yes, On top of this, I will put the plant. Okay, now we need the S3 bucket. That's our plant pot. And here we need a flower also. Where is a flower, bro? Bro, flower, plant, please, please, some plant, flower, something. I'm going to use this symbol for now. That's our flower or plant or whatever you can call it. Okay. And this is how it's going to sit. And this board you see, this will have, wait, let me draw this. How to make hole. Wait, I need to draw things. How do I draw things? These are only shapes. I can't draw. It's fine. Don't have to, don't want to draw. It's fine. But I need a 3D circle, or it's fine. Let's say I put a little hole in here. Okay, at the bottom of the pot, yeah, at the bottom of the pot, I will put a hole, and I'll also put few holes in here on the what do you say, on the surface of that board or whatever. I don't know what to call this thing, but I will put few holes in here. And our brain, our irrigation system, or our ESP, where is our microcontroller? ESP. Yes, our microcontroller will sit, which means this box will be attached to the box, to the plant. Okay. And our soil moisturizer, how do I get this thing? Sensor. Yes, this is our soil moisturizer sensor. Okay, I'm just going to flip this and I will, oh my god, this is so ugly. Anyway, it's so ugly, but it's fine. Let's make this yeah, this is our soil moisturizer sensor. The arrow indicates yes, this is what we need. Come on, rotate please. Oh, soups. No, do not do that. No. How do I rotate? Yes. Okay, this is our soil moisturizer sensor. Now, this will be connected. Don't do drama, please. This will be connected to our come on, you can do it. No. Yeah, this will be connected to come on. I think this is fine. Wait, this is not fine. This is the tough part. Come on, please. Don't do this to me. I have one idea. I have one idea. I will take the arrow from here. Wait. I will take the arrow from here. Wait. From here down here. Yeah, it's fine. This is fine. So our soil moisture sensor is connected to that thingy, and this thingy will be connected to a power supply. Okay, the power comes here. Okay, this is connected to the power supply. Now, the water, we will have one problem in here. The problem is, since we are reusing the water in here, the pump ratio, we won't be able to calculate it from the flow rate of the water, because we are using the water again. And the next question is, we'll need some kind of filter also in here. I'm just thinking out loud. I don't know if this is something that I can suggest, but this is more like just brainstorming ideas. Let's say we put a filter in here. Okay, how do I? Yeah, that's a filter. I'm just going to color this in this color. This is, what is this? This is a filter. And this is, yeah. So my motor won't be fucked up of the soil content in the water. I think this will work. And then problem is going to be the flow rate of that 5 water pump. We will need some powerful motor. Let's see water pump. Let's see what we can get. This is 12 watt water pump. Okay, what's the flow rate? Not the flow rate. Suction 3 meters or so, probably 2 meters. No problem with the vertical height is 1.5 meter. That's a good. That's a pretty good distance. Voltage, it needs 12 watt. Current at least 2 ampere. Measured 1. Flow rate is 3.5 liter per minute. Oh, that's too fast. That flow rate will kill our plant. This guy looks. This is fine for now. We'll see with this tiny water pump and how it works. Okay. Well, that we can do. Now let's get back to our planned learning thingy. Avoid letting the soil dry out completely between watering sessions. Okay, it should be moist. Sunlight. Anthuriums thrive in bright, indirect sunlight. Direct sunlight can scorch their leaves. This I have to make something like a shelter for this thing. Shelter. Roof we will need. Okay. Where is our son? Come here, son. Come. Okay. Now, this is the ugliest diagram I have ever seen. Well, yes. They can tolerate low light condition but may produce. They can tolerate low light condition but may produce fewer flowers in such environments. Ideal location include east or west facing windows with filtered light or bright artificial light. Watering frequency. Water your anthurium when the top inch of the soil feels dry to the touch. Top inch of the soil feels dry to the touch. That's actually a good point. So we don't have to put our sensor deep into the soil. We just have to measure the. Yes, I think that's a good point. The frequency of water. The frequency. Okay, on average, watering once or twice a week should suffice. Wait. On average, watering once or twice a week should suffice. But always check the soil moisture before water. In this heat, I think we have to water daily. This condition doesn't apply here. It must be applied somewhere cold. I don't know. Reduce watering frequency slightly during the winter months when the plant is not actively growing. Okay. Additional tips. Use a well-drained potting mix. What is this potting mix? I am not into plants at all. I have been hearing this a lot What is potting mix? Potting mix, also called potting soil or growing media, is a substrate used to grow plants in containers. It's usually a combination of pine bark, peat moss, perlite, vermiculite, and is often sterilized to kill. It's just more like it's protein for the plants, basically. Okay. Well, let's try one thing. A dog task. Explain potting mix like I'm 5. Imagine you have a plant. It needs to grow in a pot instead of the ground. Potting mix is like a special type of soil that's made just for plants in pots. It's fluffy and light, so the plant roots can easily grow in it. It also has a nutrient that the plant needs to grow big and strong. So when you put your plant in a pot, use potting mix to help. I don't need potting mix if I put directly in the earth soil. That's correct. If you plant your plant directly in the ground, you don't need potting mix. The soil in the ground already has everything your plant needs to grow, like nutrients and minerals. Potting mix is mainly for plants that are in plots. That's a good thing to hear. But anyway, my plant will be in a pot, so I need potting mix. Let's see. Potting mix by Amazon. $5 kg, $328. Not bad if we can grow all these things. But I need to test with something low quantity. So do we have a 100 grams is too low. Hey, 100 grams is actually a good thing. But wait, 1 kg is the Creative Farmer. I think it's a good brand based on the packing and all. Potting mixture. Let me add this to cart. We'll buy this later. Yes. Now, what are we? Wait, where is our form? Yes. Maintain room temperature between 60 F to 85. Is this a 60 F to 85? 15 degrees Celsius to 29 degrees. This is where the plan will go wrong. We have 30 above. What's the weather now? What's the weather in my area? 33. Scattered thunderstorm. Huh? Is it going to rain? Where is weather map? Weather map. Okay. Why it looks like this? It used to have some colors and everything. What is this thing? What is these lines going out? Probably the submarine cables. This map is not radar. Let's check the radar. Train, yes. This is what we need. Where am I? I hope that's the ground. Yes. We don't have a rain anywhere. Mangaluru, Chikmagaluru weather. Let's check. Chikmagaluru weather. Is it raining over there? No. Strong. This is strong. This is utter stupid. Dark weather. Thunderstorm and rain. It's raining there. How about Banaswada weather. 32. I don't know if you can trust this map or not, but Forget this. Let's get back to business. Let's get back to our planned business. Fertilize monthly during the growing season with the balanced water-soluble fertilizer diluted into half strength. Wipe the leaves occasionally. I thought it's just water and soil. Do we have to do all these things? Wipe the leaves occasionally with a damp cloth. I know we have some fertilizer, but I thought it needs for vegetables. I thought plants I haven't seen. I haven't seen anyone doing. I haven't into this gardening thing, but yeah. Wipe the leaves occasionally. Wipe the leaves occasionally with a damp cloth to remove dust and maintain their glossy appearance. We'll get another boat to do that. I think we don't have anything much. We just have to make sure that it's not soggy but just moist. That's it. And for that, I think this is fine. We can also increase this 1 hour in millisecond. That will be 36. Yes. We will check this every hour. Or wait, every hour is 2. Yes. Wait, every hour. Ideal. Okay. Now I need to do this every 10 minutes. Okay. 10 minutes. 10 minutes in milliseconds will be 6 lakh. 60000 every 10 minutes. Debugging. Okay. Now what we need to calculate is the water level. Okay. Now I'm going to we need to calculate the water percentage, the balance. How do we do that? Measure water percentage. So we will use a 1 liter source, and we also have to reduce the watering duration. 2 seconds, I think it's fine. 3 seconds will be too much. That's enough. 3 seconds is needed. Yeah. Yeah. Now the water capacity, we need to set a variable here. Water source full equals will be 1 liter, or let's do 1 liter first. Let's do 2 liters. Water source capacity 2 liter. Add the spelling of liter. Yes. Okay. Calculating the water source capacity. 2 liters. 2 liters in milliliter. Is that for milliliter? Wait, what is 2 liter? 2 liters in ml. Yes. How much ml? Yes, we will measure this in 2000 milliliters. Sorry, we'll measure this in Yeah, capacity in, okay, pump flow. What was the flow? Yes, the flow rate is 120 liters per hour, 80 to 120 liter per hour. Hmm. What was the measurement we did earlier? Where is that? Where is that? Oh, this thing doesn't have a history. So we have to ask it again. Which I will do. What's the time now? Oh, I have to do my prayers and all. I have to stop streaming. It's been 2 hours, 20 minutes. We'll continue later. Sometime later. I don't know when. Maybe tonight. I don't know. But we'll see. Thanks for everyone tuning in. I have to stop the stream now. See you again.